Chapter 1. Young Albert. Albert Einstein was born in a small German town called Ulm on March 14, 1879. His mother, Pauline, was a caring woman who loved music. His father, Hermann, was a merchant who sold feathers. Albert had a younger sister named Maja, who was his only sibling. Albert's parents noticed that he was different from other children. As a baby, he was quiet and seemed to think a lot. He started talking later than most children. His parents were worried about this, but as Albert grew older, they saw that he was just deep in thought. He liked to figure things out by himself. Their home in Ulm was comfortable, but it was not a rich home. They did not have many things, but they had enough. Albert's mother played the piano, and the sound of music often filled their home. This sparked Albert's love for music, a love he kept all his life. When Albert was 5 years old, his father showed him a compass. A compass is a small tool that points north because of the Earth's magnetic field. This compass made a big impact on Albert. He could not understand how it worked. How could something invisible make the needle move? He thought about this a lot. This was the start of Albert's interest in science. Albert went to a Catholic school in Munich because his parents thought it was the best school in the city. But he did not like the way they taught things there. They wanted students to learn by memorizing, but Albert preferred to learn by understanding. Albert's family was Jewish, but they were not very religious. They did not go to the synagogue often, and they did not follow many Jewish traditions. But they were proud of their Jewish heritage. Later in life, Albert would stand up for Jewish people and other groups who were treated unfairly. In these early years, Albert learned many important things. He learned about love from his family, about music from his mother, about business from his father, and about fairness from his own heart. But most importantly, he learned about the joy of understanding the world. This joy would guide his life and lead him to make great discoveries in science. In the next part, we will learn about an event that happened when Albert was a young boy. This event changed his life and started his journey to becoming one of the most famous scientists in the world. When Albert was 5 years old, his father Hermann gave him a small gift. It was not a toy or a book. It was a compass. A compass is a simple tool that shows which way is north. But to young Albert, it was much more than that. It was a mystery, a puzzle that he could not solve. Albert looked at the compass and saw the small needle inside. The needle was not touching anything. There was no string pulling it, no hand pushing it. But still, it moved. It always pointed in the same direction towards the north. Albert was amazed. He could not understand how it worked. How could something invisible make the needle move? He asked his father and his teachers, but their answers did not satisfy him. They told him that the compass worked because of something called magnetism. But they could not explain what magnetism was or how it worked. This made Albert even more curious. He wanted to find out the answer by himself. Albert began to think about the compass all the time. He thought about it at school, at home, even in his dreams. He read books about magnetism and electricity. He did experiments with magnets. He tried to imagine what it would be like if he could see the invisible forces that made the compass needle move. This was the beginning of Albert's love for physics. Physics is the science that explains how the world works. It tells us why the sky is blue, why the earth goes around the sun, and why a compass points north. Albert wanted to understand all these things. He wanted to solve the mysteries of the universe. The compass mystery taught Albert an important lesson. It showed him that the world is full of wonders, and that science can help us understand these wonders. It also showed him that it is okay to ask questions and to be curious. This is how we learn and grow. Albert Einstein was a very curious child. He liked to ask questions and to explore the world around him. He wanted to understand everything. But when he went to school, he faced some challenges. In those days, schools were very different from today. Teachers did not encourage students to ask questions or to think creatively. They wanted students to learn by memorizing facts and rules. They believed that this was the best way to learn, but Albert did not agree. Albert did not like memorizing things. He thought it was boring and useless. He wanted to understand things, not just remember them. He wanted to know why things happened, not just what happened. He believed that learning should be a journey of discovery, not a task of memorization. Albert's teachers did not understand him. They thought he was lazy and disrespectful. They did not like his questions and his arguments. They thought he was a troublemaker. But Albert was not trying to cause trouble. He was just trying to learn in his own way. Albert's parents were worried about him. They wanted him to do well in school and to have a good future. They tried to help him, but they did not know how. They did not understand why Albert was so different from other children. Despite these challenges, Albert did not give up. He kept asking questions and seeking answers. He kept reading books and doing experiments. He kept dreaming about the mysteries of the universe. The school challenges made Albert stronger. They taught him to be independent and to trust his own mind. They showed him that it is okay to be different, and that it is important to stand up for what you believe in. These lessons helped Albert to become the great scientist that he was. In the end, Albert Einstein did not fit into the traditional education system, but that did not stop him from learning and growing. He found his own path, a path that led him to make some of the most important discoveries in the history of science. In the next chapter, we will follow Albert as he continues his journey. We will see how he went from being a rebellious student to becoming one of the most famous scientists in the world. Chapter 2. The Path to Physics. After finishing school, Albert Einstein decided to continue his education. He wanted to learn more about the world and the way it works. He chose to study physics and mathematics because these subjects fascinated him the most. For this, he moved to a city in Switzerland called Zurich. There, he attended a school known as the Polytechnic Institute. The Polytechnic Institute was a very good school for science and technology. The teachers there were experts in their fields, and the students were some of the brightest young minds in Europe. Albert was excited to be there. He was looking forward to learning new things and meeting new people. Life in Zurich was very different from life in Germany. The city was bigger and busier. The people spoke a different language called Swiss German. At first, Albert had trouble understanding this language, but he studied hard and soon got used to it. He also made friends who helped him adjust to his new life. Studying at the Polytechnic Institute was not easy. The classes were hard, and the exams were tough. Albert had to work hard to keep up, but he enjoyed the challenge. He loved learning about physics and mathematics. He loved solving problems and discovering new things. He spent many hours in the library, reading books and taking notes. One of his favourite subjects was theoretical physics. This is the part of physics that deals with ideas and theories, rather than experiments. It involves a lot of thinking and imagining. Albert was good at this. He had a strong imagination and a sharp mind. He could think about difficult ideas and understand complex theories. During his university years, Albert grew a lot as a person and as a student. He learned to live on his own and to take care of himself. He learned to study hard and to work independently. He also learned to think deeply and to question everything. These skills would serve him well in the future. Despite the challenges, Albert enjoyed his time at the Polytechnic Institute. He learned a lot and made many friends. He graduated with a degree in physics in 1900, ready to start his career as a scientist. In the next part, we will learn about Albert's first job. It was not a job in a university or a research lab, but in a place you might not expect. This job played an important role in Albert's life and career. It helped him develop his ideas and make his first big discoveries. After graduating from the Polytechnic Institute, Albert Einstein faced a problem. He wanted to become a teacher or a researcher, but he could not find a job. This was a difficult time for him. He needed money to live, but he also wanted to continue his studies in physics. Then he found a solution. In 1902, Albert got a job at the Swiss Patent Office in Bern. A patent office is a place where people apply to protect their inventions. They want to make sure that no one else can copy their ideas. The job of the patent office is to check these applications and decide if they are new and useful. Albert's job was to review applications related to physics and engineering. He had to read the descriptions, look at the drawings, and understand how the inventions worked. He had to check if they were really new and if they could be useful. This was a big responsibility, but Albert was up to the task. At first, Albert was not very happy with this job. It was not what he had dreamed of. He wanted to be a scientist, not a patent examiner. But soon, he started to see the positive side. Working at the patent office gave Albert a lot of practice in thinking and understanding. He had to analyze complex ideas and solve tricky problems. He had to be careful and precise, but also creative and imaginative. These skills were very useful for his work in physics. The patent office also gave Albert a unique perspective on science and technology. He saw many new inventions and ideas. He saw how science could be used to create useful things. This inspired him and gave him new ideas for his own research. Despite the long hours at the office, Albert found time to continue his studies in physics. In the evenings and on weekends, he read books, wrote papers, and discussed ideas with his friends. This was his real passion, his real work. During his time at the patent office, Albert made some of his most important discoveries. He developed the theory of relativity and explained the photoelectric effect. These ideas changed the world of physics and made Albert famous. While Albert Einstein was working at the patent office, he was also doing his own research in physics. He was thinking about big questions and trying to find new answers. He was developing his own theories and ideas. He wanted to share these ideas with the world, so he started writing scientific papers. In 1905, Albert wrote 4 important papers. These papers were about different topics, but they all showed his unique way of thinking. They were all based on careful reasoning and bold imagination. They were all groundbreaking, meaning they brought new ideas to the field of physics. One of these papers was about the photoelectric effect. This is a phenomenon where light can make electrons move. Albert explained this effect using a new idea. He suggested that light is made of small packets of energy, which he called quanta. This idea was very new and very strange, but it explained the photoelectric effect perfectly. For this work, Albert later received the Nobel Prize in Physics. Another paper was about the special theory of relativity. This theory changed the way we understand space and time. It said that space and time are connected, and that they can change depending on how you move. This idea was very difficult to understand, but it explained many things that other theories could not. When Albert's papers were published, they attracted a lot of attention. Some scientists were excited by his ideas. They saw that Albert was a genius, a new star in the world of physics. They wanted to learn more from him and to work with him. Other scientists were skeptical. They thought Albert's ideas were too strange, too radical. They did not believe his theories and did not want to accept them. They challenged Albert and asked him to prove his ideas. Albert was not afraid of these challenges. He knew that his ideas were new and different. He knew that not everyone would accept them immediately. But he also knew that his ideas were based on solid reasoning and strong evidence. He was confident that they would stand the test of time. In the next chapter, we will learn about Albert's life after the patent office. We will see how he became a professor and a respected scientist. We will also see how he used his fame and influence to stand up for peace and justice. Chapter 3. The Breakthrough Year. The year 1905 was a turning point in Albert Einstein's life. It was the year when he published 4 scientific papers that would change the world of physics forever. This year is often called Albert's annus mirabilis, or miracle year, because of these papers. The first paper was about the size of molecules and how they move. This is a topic in a field of physics called statistical mechanics. Albert used a simple but powerful idea to calculate the size of molecules. He also explained a phenomenon called Brownian motion, which is the random movement of tiny particles in a fluid. This paper was important because it provided strong evidence for the existence of molecules, something that was not fully accepted at that time. The second paper was about the photoelectric effect. Albert proposed that light is made of small packets of energy called quanta or photons. He showed that this idea could explain the photoelectric effect perfectly. This paper was revolutionary because it suggested a new way of thinking about light. It was a major contribution to the development of quantum mechanics, a new field of physics. The third paper was about the special theory of relativity. This theory changed the way we understand space and time. It said that space and time are not separate, but connected into a space-time. It also said that the laws of physics are the same for everyone, no matter how they move. This theory was groundbreaking because it challenged the traditional views of space and time. The fourth paper was an extension of the special theory of relativity. It introduced the famous equation E = mc², which says that energy, E, can be converted into mass, m, and vice versa. This equation revealed a deep connection between energy and mass, and it has important implications for many areas of physics. These papers made Albert famous. They show that he was not just a patent examiner, but a brilliant physicist. They opened new doors for him, allowing him to leave the patent office and become a professor. They also sparked a lot of debate and discussion, changing the direction of physics for years to come. In the next part, we will learn about Albert's life after the annus mirabilis. We will see how he dealt with his new fame and how he continued to make important contributions to physics. One of the most significant papers Albert Einstein published in his miracle year of 1905 was on the special theory of relativity. This theory was a revolutionary new way of understanding the basic principles of physics. Before Albert's theory, scientists thought that time and space were fixed and absolute. This means that they believed time passed at the same rate for everyone, and that space was the same everywhere. But Albert thought differently. In his special theory of relativity, Albert proposed that space and time are not absolute, but relative. This means that they can change depending on how you move. If you move very fast, close to the speed of light, time can slow down for you. And space can become shorter. This idea was very strange, but it made sense mathematically. Another important part of the special theory of relativity is the idea that the speed of light is always the same. No matter how fast you are moving, light will always travel at the same speed. This was a radical idea, but it explained many experiments and observations. The special theory of relativity was a big shock for the scientific community. It challenged the traditional views of physics. It was difficult to understand and even more difficult to accept. But it was also fascinating and inspiring. It opened up a whole new world of possibilities. The impact of the special theory of relativity was huge. It changed the way scientists think about space and time. It led to many new discoveries and technologies. It also raised many new questions, some of which are still being studied today. One of the most famous results of the special theory of relativity is the equation E equals mc caret 2. This equation says that energy E can be converted into mass m, and vice versa. It reveals a deep connection between energy and mass, two concepts that were thought to be completely separate. This equation has many important implications, from nuclear power to black holes. Another remarkable paper that Albert Einstein wrote in his miracle year of 1905 was about the photoelectric effect. This effect is a phenomenon where light can make electrons move. It happens when light shines on a metal surface, causing the metal to emit electrons. For many years, scientists had been trying to explain this effect, but they were not successful. They were using the classical theory of light, which says that light is a wave. According to this theory, if the light is very bright, it should be able to make the electrons move, no matter what its color is. But the experiments showed something different. They showed that the color of the light is important. If the light is not the right color, it cannot make the electrons move, no matter how bright it is. Albert found a way to solve this puzzle. He suggested a new idea, that light is not just a wave, but also a particle. He proposed that light is made of small packets of energy, which he called quanta, or photons. Each photon has a certain amount of energy, which depends on the color of the light. To make the electrons move, the photons need to have enough energy. If they don't have enough energy, they cannot make the electrons move, no matter how many photons there are. This idea was very bold and very revolutionary. It challenged the classical theory of light, which had been accepted for many years. But it explained the photoelectric effect perfectly. It matched the experiments exactly. Albert's explanation of the photoelectric effect was a major contribution to the development of quantum mechanics, a new field of physics. Quantum mechanics deals with the behavior of very small particles, like electrons and photons. It is one of the most successful theories in physics, explaining many phenomena that other theories cannot. For his work on the photoelectric effect, Albert received the Nobel Prize in Physics in 1921. This is one of the highest honours a scientist can receive. It was a recognition of Albert's brilliant ideas and his impact on physics. Chapter 4. Einstein and the General Theory of Relativity. Albert Einstein is famous not only for his groundbreaking theories, but also for the unique way he developed them. One of his most powerful tools was the thought experiment. A thought experiment is a way of testing an idea in your mind without doing a real experiment in a laboratory. Albert used thought experiments a lot in his work. He would imagine different situations and try to predict what would happen based on his theories. He would question assumptions, challenge ideas, and look at things from new perspectives. This was a key part of his creative process. One of the most famous thought experiments is the falling elevator experiment, which played a crucial role in developing the general theory of relativity. Albert imagined a person inside an elevator, which is falling freely in a gravitational field. According to the principles of physics, the person would not feel their own weight. They would feel as if they were floating in space without gravity. This led Albert to a radical conclusion. Gravity is not a force, but a curvature of space-time caused by mass and energy. This idea became the foundation of the general theory of relativity. This theory is an extension of the special theory of relativity, which Albert had developed earlier. The special theory deals with situations where there is no gravity. The general theory includes gravity, making it applicable to a wider range of situations. The general theory of relativity was a major achievement in physics. It provided a new understanding of gravity, which is one of the fundamental forces of nature. It predicted many strange and fascinating phenomena, such as black holes and gravitational waves. It also expanded our understanding of the universe, leading to the idea of the Big Bang. Albert's thought experiments were not just mental games. They were a serious method of scientific investigation. They allowed him to explore new ideas, test hypotheses, and make predictions. They showed the power of human imagination and creativity in the quest for knowledge and understanding. In the next part, we will learn more about the general theory of relativity and its impact on science and society. We will see how Albert's ideas were tested and confirmed, and how they continue to inspire scientists and thinkers around the world. One of the most exciting moments in Albert Einstein's career came in 1919, when his general theory of relativity was put to a real-world test. This test was based on one of Albert's predictions about how light behaves in a gravitational field. According to the general theory of relativity, gravity is not a force, but a curvature of space-time caused by mass and energy. This means that when light passes near a massive object, it should follow a curved path, not a straight line. This effect is known as gravitational lensing. Albert predicted that we could observe this effect during a solar eclipse. When the moon covers the sun, the stars near the sun become visible. Their light passes close to the sun on its way to Earth. If Albert's theory was correct, the light should be bent by the sun's gravity, causing the stars to appear slightly out of position. In 1919, a British astronomer named Arthur Eddington organised an expedition to observe a solar eclipse and test Albert's prediction. Eddington travelled to the island of Principe, off the west coast of Africa, where the eclipse would be visible. He took photographs of the stars near the sun during the eclipse and compared their positions with their normal positions. When Eddington analysed the photographs, he found that the stars were indeed out of position, just as Albert had predicted. The deviation was small, but clear. This was a dramatic confirmation of the general theory of relativity. It was a triumph for Albert and a turning point in the history of physics. News of Eddington's observations spread around the world, making Albert an international celebrity. Newspapers hailed him as a genius, a new Newton. People were fascinated by his theory, even though it was difficult to understand. They were captivated by the idea that a simple equation, E equals mc caret 2, could explain the workings of the universe. In the next part, we will learn about Albert's life after this momentous event. We will see how he handled his new fame and how he continued to contribute to science and society. We will also learn about his personal life, his beliefs, and his values. The general theory of relativity was one of Albert Einstein's most significant contributions to science. It revolutionized our understanding of the universe and has had a profound impact on many areas of physics and astronomy. Before the general theory of relativity, scientists used Newton's laws of motion and gravity to describe the universe. These laws are very accurate for many situations, but they do not work well for objects that are very massive or very fast. The general theory of relativity provides a more complete and accurate description of the universe, especially for these extreme situations. One of the most important results of the general theory of relativity is the concept of black holes. A black hole is a region of space-time where gravity is so strong that nothing can escape, not even light. Black holes were first predicted by the general theory of relativity, and they have been observed by astronomers many times since then. They are one of the most mysterious and fascinating phenomena in the universe. Another important result of the general theory of relativity is the concept of gravitational waves. Gravitational waves are ripples in space-time caused by the acceleration of massive objects. They were first detected in 2015, 100 years after Albert predicted them. This discovery was a major achievement in physics, and it opened a new way of observing the universe. The general theory of relativity also changed our understanding of the universe as a whole. It led to the idea of the Big Bang, which says that the universe began as a hot, dense state about 13.8 billion years ago. This idea has been confirmed by many observations and is now the standard model of cosmology. In addition to these scientific impacts, the general theory of relativity has had a cultural impact. It has changed the way we think about space and time, matter and energy, reality and perception. It has inspired artists, writers, philosophers, and many others. It has become a symbol of human curiosity and creativity, a testament to our ability to uncover the secrets of the universe. In the next chapter, we will learn about Albert's life after the confirmation of the general theory of relativity. We will see how he dealt with his fame, how he pursued his scientific work, and how he became a voice for peace and human rights. Chapter 5. Einstein's later years. In the 1930s, the world changed dramatically, and so did Albert Einstein's life. The rise of the Nazi Party in Germany brought with it a wave of anti-Semitism, making life dangerous for Jewish people like Albert. He decided to leave Germany for good. Albert was invited to join the newly formed Institute for Advanced Study in Princeton, New Jersey, United States. This was a unique institution designed to provide a peaceful environment for scholars to pursue their research without the pressures of teaching or administrative duties. For Albert, it was a perfect place to continue his work. In 1933, Albert and his wife Elsa moved to Princeton. They bought a house at 112 Mercer Street, which became their home for the rest of their lives. Albert quickly settled into his new life. He enjoyed the quiet, small-town atmosphere of Princeton. He liked to take long walks, play the violin, and sail on a nearby lake. He also enjoyed the company of other scholars at the Institute. At the Institute, Albert worked on many scientific projects. He continued his research on the general theory of relativity, exploring its implications and trying to refine its predictions. He also worked on a unified field theory, a theoretical framework that could incorporate all the fundamental forces of nature. This was a difficult task, and Albert did not succeed in completing it, but his efforts stimulated a lot of research and discussion in the scientific community. Albert also became involved in public affairs. He spoke out on many issues, such as nuclear disarmament, civil rights, and education. He used his fame to draw attention to these issues and to advocate for peace and justice. He became a respected voice in the public sphere, known for his wisdom and integrity. In the next part, we will learn about Albert's contributions to the World War, the Second Effort, his views on the atomic bomb, and his role in the civil rights movement. We will see how he used his scientific knowledge and his moral convictions to make a difference in the world. In his later years, Albert Einstein embarked on a quest that would consume the rest of his scientific career, the search for a unified field theory. This was an attempt to bring together all the fundamental forces of nature into a single theoretical framework. The forces that Albert was trying to unite were gravity, which is described by his general theory of relativity, and electromagnetism, which is described by Maxwell's equations. At the time, these were the only two known fundamental forces. Two more, the strong and weak nuclear forces, were discovered later. Albert's goal was to find a mathematical formula, or a set of equations, that could explain both gravity and electromagnetism. He believed that this would provide a deeper understanding of the universe and reveal the underlying unity of nature. This was a highly ambitious project, and it was fraught with difficulties. The theories of gravity and electromagnetism are very different in their structure and their concepts. They describe different phenomena and operate on different scales. Bridging the gap between them was a major challenge. Despite his best efforts, Albert did not succeed in finding a unified field theory. His ideas did not fit with the experimental data, and they did not gain acceptance in the scientific community. Many physicists were moving in a different direction, towards quantum mechanics, a new theory that seemed to explain the behavior of atoms and particles better than classical physics. Although Albert's quest for a unified field theory was unsuccessful, it was not a waste of time. It stimulated a lot of research and discussion. It pushed the boundaries of theoretical physics and opened up new avenues of investigation. It inspired many scientists to think about the unity of nature and the beauty of the universe. Even in his failure, Albert showed us the value of bold ideas, the importance of perseverance, and the power of the human mind. He showed us that science is a journey, not a destination, and that the search for truth is its own reward. While Albert Einstein is most famous for his scientific achievements, his impact goes far beyond the realm of physics. In his later years, Albert became a vocal advocate for peace, human rights, and social justice, using his global fame to shed light on issues he cared deeply about. Albert was a lifelong pacifist. He was deeply affected by the destruction and suffering caused by World War I, and he believed that war was not a solution to international conflicts. He once said, "Peace cannot be kept by force. It can only be achieved by understanding." Albert was a member of several peace organizations, and he often spoke out against war and militarism. However, when World War II broke out, Albert faced a difficult decision. He was aware of the Nazi regime's efforts to develop atomic weapons, and he was worried about the consequences if they succeeded. In 1939, Albert signed a letter to President Roosevelt, warning him about this danger and urging him to support research into atomic energy in the United States. This letter played a role in the creation of the Manhattan Project, which developed the atomic bomb. After the war, when the devastating power of atomic weapons became clear, Albert regretted his involvement. He became a strong advocate for nuclear disarmament and for the peaceful use of atomic energy. He worked with other scientists to raise awareness about the dangers of nuclear weapons and to promote international cooperation in the control of atomic energy. Albert was also a champion of civil rights. He was appalled by the racism he saw in the United States, and he used his voice to condemn it. He was a friend of Paul Robeson and W.E.B. Du Bois, prominent black leaders and civil rights activists. He also spoke out in support of the newly formed State of Israel, seeing it as a refuge for Jews who had suffered persecution in Europe. In his final years, Albert continued to work on his scientific research, but he also devoted a lot of time to his social and political activities. He passed away in 1955, leaving behind a rich legacy of scientific discovery, social activism, and humanist values. In the next chapter, we will reflect on Albert's life and legacy, and we will see how his ideas continue to influence our world today. We will explore his enduring contributions to science, his impact on society, and his role as a symbol of human curiosity and creativity. Chapter 6. Einstein's Legacy. Albert Einstein was more than just a brilliant scientist. He became a cultural icon, a symbol of genius and creativity that has endured long after his death. His image, with the wild hair and the expressive eyes, is instantly recognizable and has been reproduced in countless ways in popular culture. Albert's rise to fame was largely due to his groundbreaking scientific work, particularly his general theory of relativity. The theory's confirmation in 1919 through the solar eclipse experiment made headlines around the world and catapulted Albert into the limelight. He was hailed as a scientific hero, a man whose genius had unlocked new secrets of the universe. But Albert's fame was not just about his scientific achievements. It was also about his personality, his beliefs, and his way of life. Albert was known for his humility, his sense of humour, and his nonconformist attitudes. He was a pacifist, a humanitarian, and a champion of civil rights. He was seen as a free thinker, a man who questioned authority and followed his own path. These qualities resonated with many people and made Albert a popular figure. His image was used in advertisements, cartoons, and films. His quotes were shared and cherished. His life story was told and retold in books, documentaries, and biographies. Albert became a symbol of the scientist as a creative thinker, a seeker of truth, and a servant of humanity. Even today, Albert's influence in popular culture is still strong. He is often referenced in movies, TV shows, music, and literature. His theories are explored in science fiction and speculative fiction. His image is used in art, design, and fashion. His ideas are taught in schools and debated in universities. Albert's enduring popularity is a testament to his unique combination of scientific brilliance and humanist values. It shows that we admire not only his mind, but also his heart. We see in him a model of what it means to be a scientist and a human being. In the next part, we will explore Albert's legacy in the field of science. We will see how his theories have shaped our understanding of the universe, and how his spirit of curiosity and wonder continues to inspire scientists and researchers today. Albert Einstein's contributions to science have left a profound and lasting impact on our understanding of the universe. His theories and ideas have revolutionized the field of physics and continue to shape scientific research today. Albert's most famous contribution is undoubtedly the theory of relativity, which includes the special theory of relativity and the general theory of relativity. The special theory of relativity, published in 1905, introduced the world to the concept that space and time are interconnected as a single entity known as spacetime. It also proposed the famous equation E equals mc², which states that energy E is equal to mass m times the speed of light c squared. This equation revealed the enormous amount of energy that could be released from a small amount of matter, a discovery that would later pave the way for the development of nuclear energy. The general theory of relativity, published in 1915, is a theory of gravity that describes gravity as a curvature of spacetime caused by mass and energy. It replaced Newton's law of universal gravitation and accurately predicted the bending of light around massive objects, the precession of the perihelion of Mercury, and the existence of black holes and gravitational waves, all of which have been confirmed by observations and experiments. In addition to relativity, Albert also made significant contributions to the field of quantum mechanics. He proposed the concept of the photon, or the particle of light, and explained the photoelectric effect, which is the emission of electrons from a material when it is exposed to light. This work earned him the Nobel Prize in Physics in 1921. Albert's contributions to science go beyond his own research. He played a crucial role in the development of quantum mechanics by challenging its principles and prompting debates that led to a deeper understanding of the theory. He also inspired countless scientists and researchers with his creativity, his curiosity, and his relentless pursuit of knowledge. Albert's legacy in science is immense. His theories have expanded our understanding of the universe, from the smallest particles to the largest galaxies. They have led to numerous technological advancements and have influenced many areas of science, including cosmology, particle physics, and nuclear physics. Albert Einstein was not only a brilliant scientist, but also a devoted humanitarian. His philosophies extended beyond the laboratory and the lecture hall, encompassing a deep respect for all human life and a firm belief in the power of peaceful cooperation. Albert's humanitarian philosophy was shaped by his experiences and his observations of the world around him. Witnessing the devastation of World War I and the Second and the rise of nuclear weaponry deeply impacted him. He was outspoken against the senseless violence of war and advocated for global disarmament. His famous quote, "I know not with what weapons World War III will be fought, but World War IV will be fought with sticks and stones," reflects his fear of the devastating potential of nuclear weapons. Believing in the common dignity of all people, Albert was also an advocate for civil rights and racial equality. In the United States, he spoke out against racism and segregation and was a supporter of the civil rights movement. His correspondence with leaders like W.E.B. Du Bois and Paul Robeson demonstrates his commitment to racial justice. Albert also believed in the importance of education and the pursuit of truth. He saw science not just as a tool for understanding the universe, but also as a way to promote critical thinking and curiosity. He encouraged young people to question everything and to never lose their sense of wonder. In the realm of international politics, Albert championed the idea of a global community. He was a supporter of the United Nations and believed that international cooperation was the key to addressing global problems like war, poverty, and disease. He envisioned a world where nations work together for the common good, respecting the rights and freedoms of all people. Albert Einstein's legacy as a humanitarian is as profound as his contributions to science. His compassion, his courage, and his commitment to peace and justice continue to inspire people around the world. His life reminds us that science and humanism can go hand in hand, and that the pursuit of knowledge should be guided by a deep respect for all life. As we close this book, we reflect on the extraordinary life of Albert Einstein, a curious boy who became a groundbreaking scientist, a cultural icon, and a devoted humanitarian. His story is a testament to the power of curiosity, the beauty of science, and the potential within all of us to change the world.